Michele di San Gimignano, a gelateria in northern Italy, offers several gourmet gelatos. I would like you to do parts A and B. I'll give you a couple minutes. And then we'll compare answers. Okay. So let's begin with the question. How many 2-quart batches of each type of gelato should be made to maximize revenue? Do we know how many 2-quart batches of each type should be made? No. So that's your variable. So why don't we say X? Is the number of batches of, what do we have? Yep. Chocolate hazelnut, and Y is the number of batches of, what do we got? Coffee. Oh. Good. So as stated, we're trying to maximize revenue. So let's say max. You can say maximize if you want. R or Z does not matter. I'm just going to stick with Z. Okay. How much money does the chocolate hazelnut bring in? $12.50. And we have X batches plus how much money does the coffee bring in? $8.75. Very good. And we have Y batches of those. Subject to what do we have restrictions on? Yeah. Let's go in order in which it was presented. Heavy cream, sugar, and eggs. So let's put all the heavy cream numbers together. What does that give us? Two X plus 1Y. Is that okay? And the gelateria has at most 13 cups of heavy cream, so 13. Good. Put all the sugar numbers together. Good. And someone else, eggs.
6X plus 6Y is the same.
Good. So those three are our functional constraints. And then add in your non-negative constraints because the gelateria cannot make a negative amount of gelato. Okay. So what we're going to do now is we're going to graph this. Let me copy this to the next slide. Okay. Graph it and find your corner points. Give yourself a couple minutes. you should have this as your fusible region after all three intersect. For each one, you'll be shading below the line towards the origin. Begin the last two inequalities. Say to keep it in the first quadrant. So I would shade below this line in this direction. So this big triangle here would be shaded. How many corner points do we have? Which one is it? There you go. Don't forget this guy. So 1, 2, 3, 4, 5. 3 of which are nice because they're intercepts. 2 of which are not nice because they're floating out there. So let me get rid of this. So the intercepts that we have 0, 0. What else?
8, 0, 0.
Not 8, 0. It doesn't touch the feasible region.
6.50.
6.50.
0, 7.
And then I'll just start writing 0, 7. 0, 7. Okay? So we have to find the intersection of the other two. This point here comes from the intersection of what two lines? Yep, 6x plus 6y is 48, and x plus 2y equals 14. Their intersection is 2, 6. And the last one, this point right here, comes from the intersection of what two lines? Someone else. 2x plus y is 13, and 6x plus 6y is 48. And that gives you 5, 3. And we're going to put these 5 ordered pairs into our objective function. All right, if you would take these 5 ordered pairs and put it into your objective function. I'll do the hard one. Go from there. So what does 6.5, 0 give us? Yep. Someone else, 0, 7? And 2, 6? 77 and 50? Yeah. And lastly, 5, 3.
88.75.
Yep. So what should the gelatateria do? One more time? Yep, so tell me in a full sentence. Interpret this ordered pair and that value for Z. Very good. They should make 5 2-quart batches of chocolate hazelnuts, 3 2-quart batches of coffee, and they'll bring in $88.75.